Do not scroll. Yeah, 40 JAMB chemistry likely questions. I mean, if you want to score very high in your chemistry exam, you have to be here. I mean, just stay here. Let's go. So the number one question here is, brass and bronze are both metallic alloy, right? Everybody knows that. But the question is, which is common to both of them? That is, they're asking which metal is common to these two alloys that we know. So the first thing you have to know that brass, the way I used to teach it is that brass, it looks like zinc. So brass contain both copper and zinc. Brass and bronze contain both copper and tin, right? So for the alloy, which is called brass, of course, you know what an alloy is. Is what is the mixture of what of metals, right? To improve, right, the ability of that metal, right? You don't want to use the metal alone. For instance, duralumin, for instance, creation of aircraft. So aluminum is the major metal there, but you cannot use aluminum alone. So we have to, find a way to improve the durability of that aluminum. That's why we have other mixtures, right? Like, Mn, magnesium coming together to make sure that it is really very good. So brass, just like I said, zinc. Why bronze? N, right? N. So that's but this is tin, okay? So the two metal that is common to the two of them is what? Is copper. So the answer to this question is what? Is copper. Option B. That's the answer. It's a common question in JAMB, okay? So number two, the purest form of iron is dash. A, wrought iron. B, pig iron. C, steel. And D, nickel steel, okay? Now, what is the major, or purest form of iron? Now, don't forget, we have different forms of iron. We have cast iron, we have wrought iron, we have pig iron, right? But don't forget, another question in JAMB is their uses. What we use this particular type of iron for. Okay, now, just like I said, look at this name. In fact, even though we don't know anything, you realize that pig looks like what? Pig are dirty. Exactly. So pig cannot be purest form. So the reason why they even call it pig is because it is impure. So there's no way you should miss it, right? That is clear. Because one of the things that will help you in JAMB is to know how to eliminate. In fact, if I don't know this question, you see how I'm going to get it. Now look at this one, steel. I know that steel is another alloy, right? That contain both what? Iron and carbon. Fe and carbon. That is steel. So it's not a purest form of iron because it is in itself a what? An alloy. So because it's an alloy, you realize it is a mixture. And most of the times, mixtures are what? They are not pure. You understand? So this is not the answer because it's contains iron and carbon. Nickel steel, that even makes sense, right? Nickel with steel, that makes sense. You are good to go. So the only answer by using elimination method, that is, if you have not come across this particular question before, by using elimination method, I already got the answer to be what? Wrought iron. Wrought iron is the purest form of what? Of iron. Is a common JAMB question. Okay, that's very good. Now let's look at the question. The following compound will impart a brick red color to a non-luminous Bunsen flame. That means you must know the color, right? The flame that each of these metals give. They are ions. Okay, so now let's just do a quick recap. You should know that sodium, for instance, right? This sodium we burn with what? With what we call brilliant, or if you are not brilliant, what do you say you are? You are golden. So, or gold. Sodium ion, just like I said, to burn with what? Brilliant or golden yellow. Now, there's another very important one, which is what? Is potassium. The way I know this, potassium, it starts with P, Abi. So that will be what? Purple. But some question, you will not see purple, you see what? Lilac. That is also very correct. Now, another very important one is this calcium. Now, I will give very important thing here because there's another part of calcium. There's a compound of calcium that will not burn with this particular thing. But here, you just have to know that this is what? Is brick red. Now, look at it. If it is copper 2 plus, don't also forget that there's copper 1 plus. Don't also forget that. Now, if it is copper, it will burn with what? It will burn with what? Greenish blue. Or sometimes, if you don't see greenish blue, you see bluish green. Sometimes you see bluish green. Okay, don't forget. But if it is lead, how do I know this one? B. So it is light blue. That's the way I know it. It is what? It is light blue. And if it is barium, Ba2 plus, this will go with what? With yellowish green. Now, note something. If it is just calcium chloride or calcium, what have you, you'll be seeing something like this particular question, which is what? Brick red. But don't forget, it can also be calcium carbonate. Now, if it is this calcium carbonate, this one is special. If it is calcium carbonate, you will not be seeing brick red in yours, so you will see what we call orange red. Orange red. Just take note of this, right? And don't forget, this thing, they are very, very important. You must know it. If it is sodium, sodium is, I've seen sodium before, right? I've seen the metal, but the ion of sodium, it will be burning. You will see something like brilliant or golden yellow. If it is potassium, P, purple or lilac. If it is calcium, you'll be seeing what? Brick red. If it is copper, you'll be seeing bluish green. If it is lead, B, blue, right? If it is barium, you see yellowish green. Okay, I hope that is clear. I hope you understand that very, very well. Okay, let me see my. So I hope you understand that very well. So now, so the answer to this particular question is what? What's the answer? Option C. Sorry. Option what? Option C. Option C. That's what? Calcium chloride. Because it is this one that has the ion what? Ca2 plus. So you must understand that. So now let's go to the next question. In this reaction, of course, you must know this particular reaction. I mean, this is not something you should joke with. Anyways, if you want to join our JAMB classes, you've started powerfully, right? You can send me a message here on my WhatsApp, or you can message me on TikTok if you're watching on TikTok or YouTube, anywhere. You can send me a message, okay? And we are going to also be starting operation, 7 to 7, where we'll be teaching 8 hours every day. That's going to be later, close to your JAMB exams, okay? That'll be very powerful. And if you are just new, make sure you subscribe to this channel. This is the chemistry, so you know how we do it. You know the energy, okay? So let's go. There's no time. JAMB must bow, okay? JAMB must bow. Say it in the comment section. JAMB must bow. So now let's go. In this reaction, now don't forget that this particular reaction is a very common reaction because it is important. Because this is the process in which we actually form our ethanol. So fermentation process is this particular reaction is part of the process. Okay, so it is important you know it. Now, this is how it happens in its real sense. Now, if you have starch, so that maybe yam or any form of starch is crushed, right? Now, if that particular yam is crushed, we expect that, okay, we are extracting starch. Now, that starch, the way we form starch, actually, we understand that starch is a polymer of, it's a polymer itself. So it has different monomers of glucose. Now, we know that glucose itself is C6H12O6, right? That's what we know. Now, but the problem is if you there are two main types of polymerization. We have condensation polymerization or addition polymerization. That's a JAMB question on its own. Condensation polymerization will give elimination of a particular substance, either or some people call it substance or molecule. So it's either it's giving out water or ammonia. That's condensation. What elimination? We just add the monomers without eliminating anything. Okay, those are the two types. So if this is glucose, for instance, now we have glucose, but to find a monomer, this is a monomer. To find multiple form of this particular glucose, this is what we do, because we know it's going to eliminate water, so we eliminate it from here. If you remove H2O from here, that's why you'll be having C6H10O5. But don't forget, we have to put it in brackets that, this guy is N, where N can be a lot of numbers. It can be greater than 1000 because it is monomeric aggregation of monomers. Okay, that is why you are having this here. So that's why this is represented with what? So what we have here is what we now call starch. From where? From glucose. Now, what happens is that this starch can be acted upon by this enzyme called what? Diastase. 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 So this diacetyl will act on this starch and convert this starch to this particular unit, which is a form of what? Which is like maltose. So N C12H22O11. You still follow what I taught you. Look at it. If you look at it, this looks like C12H24O12. Now, if you subtract H2O from here, you can see 24 minus 2, 22. 12 minus 1, 11. But this is maltose. But the problem is this. But this is what will be formed. Just like I told you, the aggregation, the concept is still you have to be eliminating water. Right? Now, there we can now add yeast. Yeast that we are adding contains two things. Okay, but the answer to this question, you already know that this is called what? This is what? What is it called? This is acting as a catalyst. It's not acting as a reducing agent. It's not acting as an oxidant. In this particular reaction, it's acting as a catalyst. But I just want to explain this because it's another JAMB question. So the yeast contain, it can first maltase. The maltase now will convert this particular maltose to 2 units of what? Glucose, C6H12O6. Okay? Now, don't forget, yeast also contains diamase. This diamase is the one that will now convert this guy to C2H5OH plus what? CO2. So this is ethanol. So this is the process of fermentation. So this is how we form ethanol from where? From starch. This one is in fact, if you are writing WAEC, you need to know this particular process. But yes, this is just another thing. So you should know this maltase, diamase, and diastase. So these are the 1, 2, 3. So write it in the comment section. Write diastase. Diastase is a catalyst. Write it in the comment section. Okay. So that's the answer to that question. Okay. Now let's go. Complete. Hope you get it. If you are getting it, say I got it in the comment section. Just type I got it so that I will know. And if you want me to do any other 40 questions aside from this chemistry, just name it in the comment section that let me do biology or physics or what have you. Just let me know. Okay, so let me know. Are you getting up? You're getting it. You must get it to that 300 plus. You must come back here and tell me how you scored 300 plus by teaching you all of this. Okay, now let's go. The next question is, hope you've captured this. Okay, good. The next question is complete oxidation. Complete oxidation of what? Of propa-1-ol gives dash. Now, this is the first thing. You must understand that we have what we call primary alkanol, we have secondary alkanol, and we have tertiary alkanol. Now, don't forget, when we talk about oxidation, now if this primary alkanol undergo what we call oxidation, right, partial oxidation, right, is going to give what we call alkanal at first. This is an alkanol. I will also teach you how to understand how to get primary alkanol, secondary or tertiary. I will teach you. Now, if it is partial, then if it is fully, it will be an alkanoic acid. That is the way you know. But that means the first thing you must understand is that is this propa-1-ol a primary alkanol, a secondary alkanol, or tertiary? Because that's where you will be able to know this. Now, if it is secondary alkanol, either complete or is going to just give alkanone. Tertiary alkanol will give what? This one you must not forget. No visible reaction. Write it in the comment section. Say no reaction. Tertiary alkanol gives what? Just put it no reaction on oxidation. Just put no reaction because it is a must. If you don't know it, that means what is your first job? How do I know that this propa-1-ol is it a primary? Because that's where I can get the question. Because if I get it, look at it. JAMB, I love JAMB for one thing. Look at this. Propa-1-on. Look at the propanoic. So if you don't know, you can pick any of this and you will bang it. So let's go. Now look at this propa-1-ol. Of course, you know that it has 3 carbon, right? And it means that the OH is on this. So this propa-1-ol. How do I know? I know that to know a primary alkanol or to know propan 1 is that if I start naming, I realize that this carbon is the one carrying the OH. And this carbon that is carrying the OH is attached to a single alkyl group. So this is C2H5 is attached to CH2. Or let me just put like this, C then OH. So this is how to know. I already know that this is a primary alkanol. How? The rule is this: for a primary alkanol, it must be the carbon that is attached to this OH is attached to just a single alkyl group. That's the way to know. That's the way to know. I will give you an example of a secondary alkanol now. So that means the answer to this question, they already said complete. They didn't say partial. If they had said partial oxidation, it would have been propanal. But they said complete oxidation. So the answer to this question is what? Propanoic acid. Very easy. Propanoic acid. Propanoic acid. Now let me ask you in the comment section, just do this one for me. What will be the answer? Let me change this one to propan. Let me see if you understand what I'm saying. Let me change this to butan 1O. So just drop it. What will be the complete oxidation of butan 1O? What will be the answer? If you understand this already, you already got the answer. So just drop it. Complete. I didn't say partial. Complete oxidation will give what? Now the question is, how do you know if it is secondary? I mean, let's go. Look at this. You see it yourself now. Look at this. OH. You will see. You already know what this is already. What do you think this will be? Is it a primary alkanol or a secondary alkanol or a tertiary alkanol? Obviously, it is a secondary alkanol. How? The carbon that is carrying this OH is attached to one alkyl group here, another alkyl group here. So that's why some school of thought will say this is R already, right? And this is another R. So because these are the alkyl group, OH, then H. So because it's attached to two alkyl group, we say this is a what? A secondary alkanol. So if this kind of an alkanol undergo complete oxidation, right? It would have been given what we call what? The alkanol. It will not be this. Why if it is a tertiary? How do I know tertiary? Let me just draw the tertiary for you. Tertiary is like this. Tertiary will be like this. It's very easy. I can even change this one to C2H5. Then I can change this. I can do like this. I can do like this. Then I can. You see that the carbon that is carrying the OH is attached to R1, another R2, another R3. So this is a tertiary alkanol. So if this guy undergo oxidation, what will be the product? No reaction. What will be the product? No reaction. That's a common JAMB question. Okay, these are JAMB questions. All right. So I hope you get that. So tell me you understand in the comment section. I hope you understand now. So don't forget this. All right. So this number 6. Yeah. Alkanoids are formed by the reaction of alkanoic acid. Alkanoids are formed by the reaction of alkanoic acid and what? An alkanol. ROH. That's alkanol. So the answer is what? Option B. Alkanol. Very easy. Okay. Now the question here, the 7th question here. The IUPAC name. Now this is very, very important because I have to teach you something very important here. The IUPAC name of this particular compound, right? Now you must know, I've taught you, I have a video on that. You can watch that. Also, how to name. I have quite a number of videos on that. But let me explain this. The IUPAC name of CH3, CH2, CH, CH3, then COOH. Right. Now the first thing you want to realize is that this is an alkanoic acid because it has the functional group RCOOH. Now the rule to naming organic compound is that the functional group, right, the parent name, you take that one as the major thing because that is the carrier of every other thing that is happening. So my preference is to this particular guy, right? Is that COOH? And I told you, if you watch some of my videos, I said it that you must give the least possible numbers to that particular functional group. So that is why Instead of I can number in different ways. I can start by, if I flesh this out and I do a skeletal form of um drawing, you will realize that this is the same thing as this. If I do a skeletal form, this is condensed. If I just show bonds, right? It's the same thing. Now I can number. Now how many carbon do I have? Now the rule is this. Number one, identify the longest continuous carbon chain. I call it LCCC. Longest continuous carbon chain. So now let's go. I can start 1, 2, 3, 4. That is one way. I can go like this. 1, 2, 3. It's not as long as 4. I can go like this. 1, 2, 3, 4. Yes, that makes sense. That's also 4. I can go like this. 1, 2, 3, 4. Yes, that's also 4. But will I think like that? No, because I've already, if I go like this, 1, 2, 3, 4, automatically I already gave this guy 3. And it's going to affect this particular naming. You understand? So because you have to understand the way naming are, right? You have to understand it, because if not, you are going to miss it. Now, if I go like this, 1, 2, 3, 4, that is the best way. Such that this carbon here, it is the one that I'm giving preference to, right? Very important. Now, if I go like that, that means because this guy is long enough and his boot is 4, the number of carbon is 4. And I've taught it that when you have 1 carbon, it is what? It is met. If it is 2 carbon, it is et. If it is 3 carbon, it is what? It is prop. If it is 4 carbon, it is what? It is boot. If it is 5 carbon, it is pent. If it is 6 carbon, it is X. If it is 7, it is ept. If it is 8, oct. If it is 9, non. And if it is 10, dec, right? Now, because this guy is 4, and it must, I told you that these things are just there. They are prefixes. The actual thing is the family name. So that's why this guy will be what? It will belong to the family butanoic, because it belongs to the alkanoic. I used to teach you. I've taught this very well, so I'm just making reference to that. You can subscribe. Make sure you subscribe to this channel. I'll be dropping a lot of videos. And if you want to join our JAMB classes, just like I can see my number there, you can message me. Okay. Now, because it is 4, so that means the family name would be what? Butanoic acid. Now, that is the first rule. Identify, that's the number one is longest continuous carbon chain, which is 4. Second one is identify the parent name, which we've identified. That's second rule. The third rule is what? Identify the substituent. What do we call substituents? Substituents are a group of atoms that are not part of the what? The longest chain. Now look at it. This is the longest chain, right? Now, which one is not part of the longest chain? There's a guy here. This guy is the substituent. Is the what? Is the sub, right? Is a substituent. It's not part. So it's a methyl, right? And there's an alkyl group that has a general formula of what? Alkyl group has a general formula CN H2N plus 1. So because if you put 1 here, you see something like C1 2 plus 1, which is what? 3. So because it is 1 met, but because it belongs to the alkyl, it must end with what? Hole. So that's why this one is what? Met. Then methyl. So we call it methyl group. So because of that, because that's the substitute that is here, these ones are just hydrogen atoms, right? These ones are just hydrogen atoms. They don't affect anything. They are just there. This is the only thing. Please don't make mistake. This one is not part of this. So it's here. Is the what? I just drew it out again. So now this methyl group now, the question now becomes, is on what carbon? If I start 1, 2, 3, 4, is on carbon 2. So that's why it is what? Is 2, right? Methyl butanoic acid. That's the answer to that question. So what is that? 2 methyl. So I think 2 methyl. Option A, 2 methyl butanoic acid. That's the answer. Very easy. You see, this one is 2 methyl hydroxyketone as well. That is a COOH. Okay. I hope you get that. So now let's go to the next question. Question 8. Name of the compound. Name of this particular compound. What is the name of that particular compound? The first thing I told you, right, is that you have to realize that that compound itself, it is what? It is an ester. How do I know that it's an ester or alkanoid? I know that the functional group of alkanoate is RCOOR. Now it fits in because this is one R and this is another R. So sometimes in your textbook you see this as R and you see this as R prime. Why? Because this R is not the same thing as this. It's a way to differentiate it, right? Now there's a way to name. Don't forget, I told you earlier in this particular video that I said the alkanoates, this ester, they are formed from alkanoic acid and what? And alkanol. That is the acid and the alkanol. Now the name is quite tricky because you have to call the, please note, call the alkanol first. That is the major thing here. So I will name the alkanol part first before I call the alkanoic acid. Right? What do I mean? Look at this. This is an ethyl group because it has C2H5. C2 is an ethyl. I told you earlier, right? So that means the answer to this question is ethyl because that's what I will call first, not this one. Because this part itself, all this part here is for the what? Alkanoic acid. So I'll call this part first. I'll say ethyl. Now, how many carbon? 1, 2. Ethyl ethanoate. Ethanoate. That's the answer to the question. So the name of this particular compound is what? Ethyl ethanoate. Now let me give you your own to solve. I hope you are getting it. You must get it. Oh, it is very easy. You call this part first before you call this part. So it is what? Ethyl ethanoate. Ethyl ethanoate. Because it's an alkanoate, right? So let's say I change this part to what? CH3. The only thing I'll just realize is that this part is coming from where? From the alkanol, just like I explained. So I'll call that part. So what will I say? Methyl ethanoate, because how many C is still 2, right? Very easy. Now let's say I change this part, or yes, let me say I change this part to, okay, there's one that you might not get. Let me do that one so that because of exam. Let's say I have HCOOCH3. Don't go and miss this one too. This one is very, very important too. This is a question that most people might bank, right? So how will you name this? This is what? This is, how many carbon here is 1, but this is the alkanol part. So I will still name it as what? Methyl methan, because that's this is a methanoic acid. So it's going to be methyl methanoate. Methyl methanoate. Okay? Because I know people will not get that one. So let me give you your own to solve. Let me say I change this part to C to H5. So drop the answer in the comment section. What will you call this guy? You know that this is an ethyl group. So how will you name this? So drop it in the comment section. Okay. I hope you're enjoying it. Tell me you're enjoying it so I can do more videos. Okay. Tell me, like this video if you have not subscribed, make sure you hit the subscription button. Make sure you follow us. And if you want to register for our JAMB classes, my number is here. You can message me. Okay. Now let's go. Calculate the pH of this particular concentration of the acid. Now, if I teach you this, I'm very sure you should be able to get everything. I've made a video on how to get logarithm without calculator. Is on my page. That's why you should subscribe and watch my videos. You don't need calculator. You don't need calculator to solve any logarithm questions. Like any question on pH, you don't need calculator because JAMB will not even give you logarithm. So I'll find a way to help you with that. But then now let's go. Now you have to realize that HCl is different from H plus, right? Because this is the mistake people make. Because that's why I have to find another question that will make you look at this question. This question 11. If you don't understand this part, you will miss this question 11. But let me teach you. Now, HCl is different from H plus. Why? Because the formula says that what pH equals to minus logarithm to base 10, the concentration of what? H plus, not the concentration of HCl, not the concentration of H2SO4, not the concentration of HNO3. It is H plus. That means you must find the equivalent concentration of H plus. That is where people make mistake, right? That's where people make mistake. So that means if I have this to this, that means I know that 1 mole of this guy is what gives 1 mole of this guy. So that means just for that question, this is the formula to use. Now that means for that question now, I was given 0.001 mole of what? What is it? Drop it in the comment section. It's of what? Don't say H plus. So it is of what? HCl that was given. But because I just know that because it is 1 mole to 1 mole, if I have 0.01 mole, sorry, 1 molar of HCl, it is going to be the same thing as 0.01 molar H plus. Because in this case, it is H2. It will not be the same way. That's why I'm teaching you this thing. It will not be the same way. So that means I cannot use this guy because that's what is in the formula, not this one. Because you must understand it. It is just sometimes you are lucky. I remember when I wrote UI post in 2018. Is it 2018 or 2017? This particular question was asked. The one that was asked was this one. And most students missed it. They pick it was even 0.001 molar. So they picked 3. The answer is 2.7. I can never forget because it's a question they asked me in my UI post. Of course, I'm a final year medical student in the university, but I'm in 600 level right now. But yeah. Anyways, if you want to join our JAMB classes, my number is here and subscribe. I'll teach you, don't worry. I entered UI with 314, so it's not beans. I have the experience. I did JAMB 3 times, so I have the experience, I have the exposure, I have the expertise to hold your hands to the next level. Okay, just send a message to join our JAMB class. Marathon will happen. Operation 7 days to proceed to UTME exams. Very powerful. So don't worry, I got you. Now let's go. So since I got this, now let me put it here. So I will say pH equals to what? Minus logarithm to base 10. What is now? Now don't forget that I can convert 0.001 molar to standard form. I need it. I will tell you why. How do I convert it to standard form? Just the way the way my secondary teacher taught me is that after this point, I'll just count 1, 2, 3. If I want to carry everything, 1, 2, 3. So I will carry 1, 2, 3. So I've carried it to the end. So that's 1 times 10 raised by what? Minus 3. So that's where my secondary teacher taught me. Right? So why is it like this? Why is it minus 3? It's because I'm taking everything to the left side. If the way this board is facing us, because I'm taking it like this, can you see I'm taking it to the left? But if I'm taking it to the right, it will be positive. If I'm taking it to the left, it will be negative. Do you understand? So that is why this is minus 3. But let's say I have 1, 2, 3, 4, 5. And I carried it like this. 1, 2, 3. So this will be 10. Or if I want to even carry it to this place, I can carry everything. But if I want to carry it to this place, or just let me stop here. Let me just so that I can explain. So this is 10 times 10 raised by what? How many times did I carry? 1, 2, 3. I stop here. Can you see it is 10 I wrote? So it will be 10 raised by 3. It will not be minus, it will be plus because I'm carrying to the negative, to the right hand side. But let's say I want to carry everything. This is just by the way. 1, 2, 3, 4. I've carried everything. So it will be 1 times 10 raised by what? I counted how many times? 1, 2, 3, 4. So I carry, so it is positive, not negative. So that's the concept, anyways. But that's not what I'm here to teach you. But for your math exam, you can use that. So this will be what? 1 times 10 raised by what? Minus 3. I made a video on all these things already. But yeah, this is our question based. Now, when I get here, I used to tell my students, I've taught it very well. I used to tell my students, don't solve. Now me talk am. What did I say? Drop it in the comment section right now. What did I say? Immediately you get to this particular level, that you've substituted your H plus already, do not what? Do not solve. Tell them, now me talk am. There's a secret. What do? Just say that pH is equals to what? Just carry what is here. 3, not the minus. So just carry the 3 minus log what is here. Minus log 10 base 1. That is the answer. You can quote me anywhere. You can press this in your calculator. The minus is here, I don't care. But this is the answer. Now me talk am. It works. I've taught it before. Subscribe, you will see it everywhere. Right? That's the answer. And I know that log 1, I taught it already. Log 1 is what? Is 0. So that's why I know that this is 3 minus 0. This is what? Is 3. So pH, the answer is what? Is 3. You might think is a fluke. Let me check. This is the answer to this question. The answer is what? The answer is 3. The pH of this one is what? Is 3. Now, you might think it's a fluke. Let me say I change the H entirely to, let's say, 2 times 10 raised power minus 8. Let's say what they gave me. What did I tell you should do? Don't solve, Abi. Just carry what is here. pH is what? 8 minus log what is here? Log 2. That's the answer. You can quote me anywhere. Press in your calculator and press this and press it. You get the same answer. You get the same answer. Right? And I can also tell you that I know what is log 2 already. Log 2 is 0.3. I've taught it. That's why you must be following my you must be subscribing and following me. It's on my video already. I've taught you how to get log 3. Subscribe now. So this is 0.3. You can also go and test it. So 8 minus 0.3 is what? Is 7.7. You can also test it. That's the answer. That's the answer. You can test it. So let me give you your own to solve, right? Let me give you your own to solve. Let me say this is 2. Let me put what is here. Let me put 5. You will solve it. See, let me tell you, the secret here is that as I'm solving this question from JAMB, I have JAMB in here. As I'm solving these questions, I'm also giving you are solving. If you don't reply in the comment section, I will stop doing video for you. So as I'm solving for you like this, I'll be giving you questions to solve. So you must just bring your book and be solving with me and be dropping it in the comment section. Yeah, what will you do? I already told you, just put what is here, 5 minus log 2. And I already told you log 2 is what? 0.3. Yeah, drop in the comment section because I will know. I will check. Okay, that's what 5 minus log 2 abi. Yeah, drop in the comment section. So let's move. Question 10, right? Question 10. We are going to 40. So it's JAMB. I'm using JAMB Pack. It's here. So I'm using JAMB Pack. I see. It's here. So there are questions that they will ask you. So they are likely questions. Okay. So now let's go. Let's go. Now, what is the color of litmus paper in acidic medium, right? Now, the way to know this one, the way I used to know it, but just know it that there's a way. If I want to teach you, I already made a video on that, on how to know the mnemonics. I taught it, how to know in acidic medium, in basic medium, and neutral medium. But for this one, for the sake of this, just know bra. You know bra now. Sorry, apologies to the ladies. I just have to teach it like this. I'm sorry. You know the bra that the ladies wear, right? So apologies to them anyways. But the point is, you just have to learn. Any way to learn. This space, we have to pass. So, right? So, if you know that, that means I can get the answer to this question. That means for A means what? Acid. So, what does bra? Blue litmus paper will turn what? Red in acidic medium. That's bra. Now, if you are very smart enough, you already know that in basic medium, what will be the answer? It is the opposite. Red will turn what? Blue. So it is the RBB. Okay? Then bra. So most of the times in things like this, I don't tend to learn this one. I just learn this one because this is easy. So if I know bra, I know it is blue litmus paper will turn red in acidic medium. I know the opposite to be red litmus paper will turn blue in basic. So I don't learn this one. I just learn this one. That's the way to learn very fast. So the answer here is what? Blue to what? Blue to red in acidic medium. Okay? Very easy. Now, let me now solve this question 11. That will now reinforce what I taught you in question 9. So let's see. So hope you get this. So yeah, put it in the comment section. Put BRA, bra, in the comment section. They should not understand. Then they will be wondering, why are these guys learning chemistry at all? We want to learn chemistry with fun. Okay? You don't have to complicate it. It's not hard. It's not hard. Even though in my own level, I had like maybe 93 or 94 in one of my chemistry. So it's not hard. You have to learn it with fun. It's not hard. Okay? Put bra in the comment section. Just like we must be learning together. Say. So now let's go. Calculate the pH. The pH of what? 0.0001 molar H2SO4. Okay? Now, just like I told you, the same way. Let's go. This place now, if you go and do it the other way around, you see that you bang it. You will see the answer now. You see what you would have gotten if you had done it the other way around. Let me teach you something. Now, don't forget that this guy will dissociate, right? And form H plus SO4 2 minus. Don't forget, because this is 2, this will be 2. That is where the problem is. Because the basicity of this guy is 2. The maximum number of replaceable hydroxonium ion is 2. Unlike this one, that the basicity of ACl is 1. I think there's a question on basicity. Good. This one. This one is a JAMB question. This one, they asked me self in my JAMB. But don't worry, we'll get there. So the basicity here is what? Okay, let me just ask you another question. What is the basicity of H3PO4? You already know. Oh yeah, drop in the comment section. You must be learning. I know people that are following. So as I'm giving you this question, I know. So I'll just be checking. Those that are following. Those that are following. So now, but what did they give me? It is for H2SO4. It is 0.0001 molar H2SO4. But that's not the case, because in pH, the formula is minus log to base 10 H plus, not H2SO4. So I must find the equivalent, because this is 1 mole to what? 2 moles. So that's why this will be what? 2 times 0.0001 molar H plus. So this is what I will now use in this space. So that's where students make mistake. This is where students make mistake. That's where we to do to understand the concept. So by this, I already taught you that 2 times this will be what? Will be 0.00. You know how to do it now. 2 times 0, 0. 2 times 0, 0. 2 times 0, 0. 2 times 0, 0. 2 times 1, 2 molar. Of what? Of H plus. So from here, what will I do? I can convert this. I taught you how to do it. If you are moving to the what? To the negative, to the left side, you count 1, 2, 3, 4. So that's why this is 2 times 10 raised power minus 4 molar of H plus. So this is what I will now substitute in this place. So I would still teach you that same way. If you have been following, you will see that this is your. I know you will trust me that. I know by now you know that. Well, you know what this answer would be. You know now. Oh yeah, what did I tell you to do? Don't solve. Don't be opening brackets, open minus, do all those. Why are you stressing yourself? When you get here, just pick what is here. 4 abi minus log what is here? Log 2. Exactly. You are good. You are done. Look at you. You have used 2 seconds. Some people will be using 30 minutes to solve this one. So you just do 4. That's why you have to be here. Me, I'll give you different tricks. Log 2, I already told you is what? 0.3. Just put it here. So this is what? 3 point what? 7. Kojubelo. You're good. You're good to go. That's it. You can go and test. You can go and confirm. We'll press this on your calculator. You get the answer. So let me give you your own. You must be solving. You'll be tired of me because you must pass. Oh yeah, let me change this one. Let me change this one to 10. Oh yeah, tell me the answer in the comment section. Tell me the answer in the comment section. Okay, you must be passing. So the answer to this one is what? 3.7. 3.7. Okay, 3.7. Now let's go. Basicity of an acid. Now I would have explained this concept very well, but I've done a video on that already. But let me just give you an hint. Basicity of an acid is the maximum number of replaceable hydrozonium ion in 1 mole of an acid. What did I say? In 1 mole of an acid. Look at it. If you observe, it is 1 mole of this acid. Because if I change this to 2, this might change. Not even might, it will change. Okay. So that's what they will talk about basicity. So I will just explain that. Then we move. I hope you are getting value. Type value in the comment section. Type value if you are getting value. Type value. So question 12. What is the basicity of H3? Now, this question, the reason why I have to bring it out is that it is a JAMB question. And of course, it is a repeated JAMB question. Let me put it that way. Now, what did I say? Is the maximum number of replaceable hydrozonium ion. Now, JAMB will put option A 4, option B 2, option C 1, option D 5. Now, the answer to this question, please note, this guy is an alkyl group. Is not what we are talking about. It's not replaceable here. There are some reactions that can replace it, but not this one. So what am I trying to say is that this guy is the basicity is not 3 plus 1. That's why they will put it as option A. The basicity is what? Is 1. It's only this hydrogen ion here. When you do it like this, RCO minus then H plus, it's only this one that is replaceable. So the basicity of ethanoic acid, because this is an ethanoic acid, you can see it's 2 carbon. Ethanoic acid is what? Is 1. It's not 4. It's not 3 hydrogen plus 1 hydrogen making 4. That's why option A will be 4. So the answer is what? Is 1. So this is a common JAMB question that people miss. Okay? Very good. So let me give you your own. You must be solving, what is the basicity? So it's even easy. What is the basicity of H NO3. So drop the answer in the comment section. You must be solving as we are going. That is my own. If you don't want to solve questions, I'm not for you. You must be solving questions. I'm teaching you. You must be solving. So let's go. So that's the answer. Very easy. So when you have, the idea is this. Let me just give you. When you have AC, I'm not teaching you this one. You do this one. When you have it dissolving water, for instance, you see that this guy will just give H3O plus, then Cl minus. So this is what they call hydrozonium ion, or sometimes people call it ozonium ion. So this is what is referred to as basic, which is 1. You understand? Because when you dissolve it in water, you can see H will come here. So it will come H3, then the O, then the plus, then Cl minus. Okay? So, but this is what I'm more important. So if it is this, you see it is 1 because of this only one. This one, you know what it is already. If it is H2SO4, you know what it is already. It is 2. If it is H3PO4, you know what it is. It is 3. So, but what is this one? Drop in the comment section. Let's move. Question 14. Sodium hydroxide absorbs CO2 to form dash. Sodium hydroxide absorbs CO2 to form dash. Okay. Sodium hydroxide absorbs CO2 to form that. Right? Now, you know that sodium hydroxide, right, is a base. Sodium hydroxide is a base. Right? And you know the concept of what? Alkali and soluble base, because all alkali are bases, but not all bases are alkali, because not all base dissolves in water. You understand? For instance, copper oxide now will not dissolve. Okay. Now, so but this one is one of them. So this guy can dissolve. So this guy is both an alkali and a base. But this guy can absorb CO2. Now, if this guy absorbs CO2, it will form what we call what? Na2CO3, right? This was sodium triazocarbonate. You know that sodium triazocarbonate. But if I want to go deep, I'll say triazocarbonate what? What is the oxidation number of carbon? Triazocarbonate 4, right? So this is the answer to this question. This one will form Na2CO3. Na2CO3. Okay? Now let's go. There's no time. You must just learn. But okay, I think I should ask you another question. The process of forming, there's a industrial preparation where we form sodium triazocarbonate or sodium hydrogen triazocarbonate. You remember that? What process is it called? Go and find out. It starts with SOL. Go and fill it. So I don't want to tell you. So I want you to go and know that, oh, you must be learning. So what is that process called? I already told you already. I just want you to learn it very well. So now, in Haber process, finely divided ion is dash. You know Haber process already, right? What do we use Haber process to do? Haber process is the production of what? Of ammonia, right? When we want to produce ammonia, N2 plus H2 gas to give ammonia, right? So I know that the ratio is very, very important because this one must be this and this one must be this. So in ratio 1 to 3 to 2. So this is what we call what? Haber process. But the problem, the most important thing here is that there is a particular catalyst that is used, and that's finely divided ion catalyst. So it is used as a what? A catalyst. So that finely divided catalyst ion is used as what? As a catalyst. That's the question. Now, contact process is a very important process in chemistry. You must understand the process. So I will use this video to explain. Now, for contact process, right, you must understand that that is the preparation of what? The king of chemicals. The king of chemicals. What do we call it? Who do we call the king of chemicals? I mean, Oba, I want chemicals. Because the concept is that its production alone can be used in the production of many other chemicals. So that is H2SO4. Now, how is it produced? The first thing is that sulfur is passed through, to what? Oxygen. Now, this passing of sulfur to oxygen will form what? SO2. This is the process. Now, this SO2 is now passed with what? With excess oxygen. So now form what we call what? SO3. This is what they call what? Sulfur 6 oxide. This is sulfur 4 oxide. This is sulfur 6 oxide. Now, this SO3, right? The vanadium 5 ox. I think the question here is that dash is so the answer here is V2O5. So this is what they call vanadium 5 oxide, in case you don't see it as a compound. So this is what they use as a catalyst. Okay. Now, that's not where I'm going. I just want you to understand that this SO2, you cannot just, you know, react it with water, because look at it. If you react it with water, SO3 plus H2O, automatically this guy will give what? H2. Look at H2. How many S? 1. How many oxygen? 4. But this is not the way it is done. If you do it like this, it is highly exothermic. If you do it like this, if you just go and dissolve SO3 into water, it's highly exothermic. So you don't do it this way, because they understand this process. You don't dissolve it like that. So what they do is that they first take this SO2, they first pass them, they find some H2SO4 already. They find it and dissolve it inside. So if this is happening, look at it. It's now from H2. How many S? S become 2. How many O? Sorry, it's not O3. It's not O2, it's O3. How many oxygen? O7. So this thing that is formed here is what they call oleum. So this is the second question here. During the contact process, SO2 reacts with H2SO4 to form what? Oleum, which is what? H2S2O7. Now it is this oleum that they now dissolve in water. It is this oleum that is now being dissolved in water. Now look at it. Look at it. If I is going to give what? H2SO4. Right? Now I'll tell you why. Look at it. H2 becomes what? How many? 4. So that's why it is 2 mole. Just look at it. How many H is here? 4. 2, 2. 2 times 2, 4. How many S is here? S is 2. S becomes 2. How many O? 7 plus 1, 8. So 2 times 4, 8. So that is the way they form. This is the, in fact, this is, if you are writing WAEC, you should know this process. So this is where V2O5 comes in. Vanadium 5 oxide, which is the catalyst. So this is the whole process. You have to first dissolve it in, find small H2SO4, dissolve in it to form oleum. Oleum now pass through water to now form this. So this is, I've taught you contact process like that. You are good to go. Any question on that? So what is the compound that is being formed when SO2, that is, why am I saying SO2? When SO3, sulfur 6 oxide reacts with H2SO4, is what? Oleum. H2S2O7. So let's go. Question 18. The gas that gives brown coloration in brown ring experiment. Of course, you know that brown ring experiment, that's nitrate, right? Nitrate. You must know that. But the question is not about that. The question is, what gas is responsible? This is what we use brown ring experiment. But what gas is responsible for that brown, that ring form? That brown ring form is what? Is NO. Please, this one is a JAMB question. Of course, all the questions I'm teaching is a JAMB, but this one is a common JAMB question. Let me put it out. When I say this one is a JAMB, it means like I've seen it before. That's why I'm trying to emphasize it. So, NO, that's nitrogen 2 oxide. That is the word we for that brown ring appearance. But the test itself is for NO3 minus, which is nitrate radical. So please take note of that. So that's that. Now, chlorine water after exposure to sunlight gives dash. See, this is very, very important because I made a video on it, right? If you check my page, you'll see, but I'm going to teach you again. Now, chlorine water, the concept of chlorine water itself, there are something I have to tell you about it, because JAMB asks a lot of questions apart from just this chlorine water of a thing I just said here. Now, what's happened is hypo, right? You know, the concept of hypo that is everywhere, but that's not what I want to teach you. Hypo has a particular compound inside, and it's this particular concept, right? Now, this is what hypo did. Chlorine gas, when they dissolve it in water, right? So when they dissolve this guy in water, they realize that they can form HOCl plus what? Plus HCl. See, I'm just teaching you chlorine water, this concept, and I'm going to teach you other things. Right? Now, if you look at this very well, you understand, you realize how many H2 balanced, how many oxygen 1, how many chlorine 2 balanced. Now, this guy, HOCl, is what is responsible for this hypo that we are calling. So this is in the trivial name, the old name, is called hypochlorous acid. So this is where they got that hypo that people are drinking now. Anyways, this is where they got the name hypo from because of the old name. But that's not the new name now. The new name of this particular guy is what? Ozochlorate 1 acid. But that's not where I'm going. Where I'm going is that what after you expose this guy, so the way I used to draw it is the way this is how it happens. You know what they mean by after exposure is that when you use it to wash your clothes, what do you do to the clothes? You spread it to the sunlight. That is what it happens. But that's what they are trying to say. But this is the way we used to draw it. So when you this is the chlorine water. So this guy now, mixture of this guy together is called chlorine. You can have bromine water too when you have bromide, um bromine with water. But that's not where I want to I just want you to know that HOCl, right? Plus what? HCl. When you now have something like this, right? You now have rays of sunlight coming from this axis, right? Coming on it. So now this exposure of this guy, we now allow let me explain this side. Ozochlorate 1 acid, that's the new name, okay? We now allow what happen. Look at it. You now see that HOCl we now combine with the dye, right? Now it will now give what? Look at what I will write. HCl will come out, but there's oxygen, right? O2 plus what? The dye. So this is the balance equation because there's observe that the dye here is like the clothes that they use. So what am I trying to say is that after exposing, there's a gas that will be leaving, and that gas is what? Is oxygen gas. This is a question in JAMB. But that's not the only question, because the answer to this question is that chlorine water after exposure to sunlight gives dash. It gives oxygen gas. That's the answer to this question. This one is NO, right? It gives oxygen gas. That's the answer. But the question, another JAMB question is that chlorine water or chlorine bleaches by dash. That's the question in JAMB. A, reduction. B, oxidation. Please never forget. If you know that one of the way we define oxidation and reduction is what? Addition of oxygen. So chlorine water bleaches by O2 adding. So that's what? It bleaches by what? Oxidation. Never forget, this one is a JAMB question. I've seen it before. It bleaches by what? Oxidation. But another question that they used to ask is that what kind of material do we use chlorine to bleach? And the way to know is that chlorine starts with C. So what is the C that starts with C? Is what? Cotton. Cotton. Plant material. That's what we use chlorine to bleach. But another question is that SO2, which is what? Sulfur oxide, bleaches by what? Dash. This one you have to also know it because it's the opposite. This one bleaches by what? Reduction. It bleaches by what? Reduction. It bleaches by what? Reduction. Addition of what? Hydrogen or removal of oxygen. That is where it bleaches. But what do we use to bleach? What is sulfur? SO2, sorry. And what do we use it to bleach? We use to bleach S for S, silk, animal silk, animal silk. It's very easy, right? Very simple. S for S, silk. Okay. So that's those are I've put. In fact, on this question alone, I'm doing like 4 JAMB questions or 3. Chlorine bleaches by what? Oxidation. SO2 bleaches by what? Reduction. What are the materials we use to bleach? For S is silk, for C is cotton. Don't forget. So let's move. Now, allotropes, right? Allotropes. Now, most of the people don't understand that the concept of allotropes is very easy. Okay. Now, allotropes is different from allotropy. Allotropy is a phenomenon or is an occurrence, but allotropes are the substance or element that exhibits the allotropy. It's like a phenomenon where we have substances exhibiting that phenomenon. All right. So when we say allotropes, allotropes are substance, right? That have the same words. Okay, the question is here. Have different, is that they have different chemical composition, but same physical state. And I will give you an example so that you don't forget. Look at, for instance, look at diamond and graphite. They have allotropes, right? Now you realize that 2 of them are both solid, so their state is the same. But you know that, in fact, they used to tell you that if you know the hybridization of this guy, you say that, oh, diamond is sp3 hybridized, this guy is sp2 hybridized, different shape. They are layered. This one is stronger. This one is this. But the point is, you see that the structure, the chemical composition of diamond is different than this. You hear that graphite can be used in making lead pencil and all of those things, right? So they are different, but they have the same physical state. Physical state. Physical state. All right. Physical state. Physical state. Very important. Another very good example is what? Oxygen and ozone. They are both gases, but they are different. So these are allotropes. Another very fantastic example is what? Is sulfur. We have different allotropes of sulfur. We have rhombic sulfur. We have monoclinic sulfur, right? We have amorphous sulfur. But all of them are all solid, right? But they have different things. Another thing that is important is that they can ask you the transition point of sulfur is what? Is 96 degrees Celsius. Or sometimes we say 98 degrees Celsius. But just don't forget. But yeah, that's that. So now this question 21. I hope you get this. Please don't forget to. These are allotropes. Now, question 21. This one is very, very important because it's a JAMB question. Okay, don't let me say that. But it's what I mean, like, you understand what I'm trying to say? When I say it's a JAMB question, I already told you. I mean, like, I've seen it before. When iron sulfide reacts with dilute HCl, the gas evolved dash lead acetate paper. What happens to the gas evolve? What does it do to the lead acetate paper? Now, because when this reacts, right, this guy will give FeCl. Now, there's also another concept about this guy, right, that you must know. But let's say this guy give FeCl3 plus H2S. I'm not even about this. There's something I would teach you about this guy. How they tend to form an higher oxide. Sorry, an higher oxidation state. But this is where I'm going to. This is the gas. It's not a gas. This is solid. This is the gas. Now, this H2S, right? Lead acetate. Lead acetate. In fact, some textbook will tell you that lead ethanol heat. Like, what happens to this guy? Is that this guy, what happens is that it turns lead acetate, or what they call lead ethanol 8, PB. Now this is 2 plus, it will now cover this as this. You know that already. Because this is what? PB2 plus, right? So this guy that is involved, we now give this guy as what? CH3, COO. The HL will come here. Then this will what? PBS, right? Now, this particular reaction, it's going to what? Is a black deposition, right? It precipitates with a black deposition because of this particular thing that is being formed here. So there's a black, is blackened or darkened. You must see that black precipitate, black deposition. So the answer to this question is that the gas evolved dash it's what? It darkens or black. It's released what? Black deposit to lead acetate paper. So the paper will become dark. It's become dark like this, or this chalk, this marker you're saying. So that's the answer to that question. But just note how I was able to explain it. So this guy is one that now reacts with the lead acetate paper to now release this. Okay? This was the JAMB question right here. Now, question 32. Hydrogen sulfide. See, hydrogen sulfide is a very, very important compound because it behaves somehow. You have to understand it. Now, this question, the way I used to explain it is, if I teach you, I can teach you, I will teach you how to get the answer. But most of the times, this one is a common answer. So I will teach you how to know that this is the answer. Now, when H2S reacts with SO2, right? Now, look at it. Ideally, SO2 is a reducing agent. H2S is also a reducing agent. But someone we have to bow. Someone we have to bow. That is it. Now, let me just teach you something. When this happens, you will see H2O plus S, right? I will use another video to explain redox and maybe I will use the other one, but just let me teach you something. if I want to go like this, if I treat this guy here, if I treat this guy here, right, you know that oxygen state of this guy is 0, right? Now, this is what? Sulfur 4. So this is 4, right? If I calculate the oxygen state of S here, it will be -2. This is +1, +1, -2. But that's not where I'm going. I just want to teach you something. That means I cannot use this one to go with this. That means it's only S and S I'll compare. So -2 to 0. What happens to that? That's what? Increase in oxygen state. And anytime they have increase in oxygen state, what do we say? That is what? Oxidation. In fact, that's the most ideal way to know oxidation. Either when they say addition of oxygen, it's not all cases you have addition of oxygen, removal of hydrogen. But 4 to 0, that is what? Decrease in oxygen state. That's the standard definition. God, that's the one that will help you. So that's what? Reduction. Now, how do I know oxidizing agents? Or that is a rule of thumb. The one that undergo oxidation will be a what? Reducing agent. The one that undergo reduction will be an oxidizing agent. But why is this happening? But the answer to this question is that H2S act as what? As a reducing agent. That's the answer. But that's not the problem. That's not the point here. The point is that SO2 is actually a reducing agent, but in the presence of a very strong reducing agent. Just like some of you. Some of you are the first in your class, but when you get to university or when you get to some places, you go down because you have met a very higher reducing agent. So that's what is happening here. SO2 is a reducing agent. H2S is a reducing, but it depends on a very strong reducing agent, which is H2S. SO2 has to bow. That's why it's bound to go and take the other position, which is what? Oxidizing agent. I hope you get it. So please don't forget that. There are a lot of things about H2S. Very, very important. Which gas is used in the intermittent supply? In fact, this reaction itself is what they use in intermittent supply, and it is used in what? Keeps apparatus. So which gas keeps? I made a video on this. Hope you have subscribed. Hey, don't worry, yo. Keeps apparatus. What gas is used? I made a video on that already. So tell me, is H2S? So drop it in the comment section. What gas is used in the intermittent supply? There's a gas that when we need it, intermittent is that when we need it, we just ask for it. Boom. I've made a video on that. Go and subscribe. Hope you have subscribed to my channel or follow me on YouTube. And if you want to join our WhatsApp class, right, you can message me here on my WhatsApp or message me on TikTok or anywhere you're seeing this video. So keeps apparatus is what? What is the gas? H2S. Drop it in the comment section. H2S. I hope you learned something. So, question 23, right? Calculate the oxygen state of the following oxygen number. Now, this I've repeated question they've asked on calculating oxygen state. So that is question 23 to 26. And I want to use that to explain to you, right? In my own exam, they asked me this one, and I can never forget. In 2017, when I wrote my first JAMB, they asked me this one. So let's go. Now, there are rules to oxygen number, right? I'm not going to explain that, but I just want to give you how to calculate this. But first of all, note that the oxygen state or oxygen number of any compound. Now, please, unlike here that they asked me calculate carbon in this, calculate manganese in this, calculate chromium in this. If it is a compound like this, it is what? 0. That's why the formula that we used to use is that the oxygen state of a compound is equal to 0. That's the first thing we do. So that's why we do CaCO3 equals to 0. That's the first rule. Now, I need carbon. This is what I need. I will say this X. So calcium belongs to what? Group what? Group. You know how the group, right? And the period. It belongs to group 2. And if I know that calcium is the last element in the periodic table, right? And that's atomic number of 20. So that means I'll just use 2, 8, 8, 2. So I know it belongs to group 2. And the period what? 1, 2, 3, 4. Right? I've taught you that by using the electronic configuration to get a lot of things. Okay, but this is what I need. So, but what is important that this belongs to? That's +2 plus X plus 3 of oxygen equals to 0. Let me still write Ca here. Then Ca is +2 because that's the valency. not the valency, sorry, this is the oxygen number of calcium. Valency will not have a charge. The difference between oxygen number and valency is that in oxygen number, there's a charge. In valency, there's no charge. So this is plus x plus 3 minus 2. Same thing with oxygen equals to 0. But oxygen is minus 2. So that's plus 2 plus x minus 3 times minus 2 is minus 6 equals to 0. Now, plus 2 minus 6 is what? Minus 4 plus x equals to 0. So when this comes to this guy, s becomes not 4. That's another mistake. If JAMB put 4, you miss it too. Unless they ask you calculate the valency. Is oxygen number that they ask? Oxygen number is the combining power of an element with a charge. Why valency number is the combining power of an element without a charge. In fact, I asked that in my secondary school. I remember vividly when they taught us valency and oxygen number. I asked that, ma, what was the difference between oxygen number and valency? And I can never forget that definition. That was what she told me. Until now, I still remember that. So remember that oxygen number has a charge, valency does not have a charge. So that's why this one is what? Plus. It is plus. It is only in chemistry that plus 4 is different from 4. All right. Hope you know that. So the answer to this question is what? Is plus 4, not 4. Plus 4. Now, the second question, manganese. This one is a very common question. KMNO4 and K2CR27. They are oxidizing agents. So they are very important. Okay, so now let's go. Same rule applies. You just go like that. KMNO4, everything equals to 0, right? And you know that potassium is in group 1. So the valency is what? The oxygen number is what? Plus 1. I need Mn. Same thing. Oxygen is what? 4 into what? Minus 2. You must know oxygen. There's no way. You can see oxygen is here, oxygen is here, oxygen is here, oxygen is here. Oxygen is in everything, so you must know it. Plus 1 plus x minus 8 equals to 0. 4 times minus 2, that's it. So this becomes plus 2 plus 1 minus 8 is what? Minus 7 equals to 0. So x equals to what? Plus 7. So that's why we name this as what? Potassium tetraoxomanganese 7. That's why we name this one calcium trioxocarbonate 4. That is the IUPAC name. This thing is sweet. Now, this one, they asked me this one. I can never forget this because I almost miss it. I will tell you why. I almost missed this one. So that's why I can never forget because I almost picked 7. But the answer is not 7. The answer is what? Plus 6. Plus 6. What did I say? Chromium in K2Cl2O7 is plus what? Plus 6. Plus what? Plus 6. Good guy. Yeah, in fact, put it in the comment section. Say plus 6. If you want to join our JAMB classes, as always, you can message me here on WhatsApp or you can send me a message on TikTok anywhere. So this is what you see. It's still the same plus 1, but don't forget it's now 2 of it. 2K. This one too is 2Cr. Then 7O equals to 0. So you just start putting 2 into plus 1 plus 2 into Cr. That's what I need. I can replace it with X plus 7 into what? Oh yeah, tell me, what is oxygen? Tell me now. Minus what? Minus 2. Good girl. Good guy. Minus 2 equals to 0. I hope you are enjoying this. See, I'm sweating, tired. We have to make you pass. You have to pass. You have to come back here and say, oh, you helped me. Hope you are getting value. Say value in the comments section. Type value. Subscribe if you have not subscribed. I'll be uploading biology very soon and physics. Or which one do you want me to upload next? Just type it in the comment section. If it's biology or physics or more chemistry, just type it. Your wish is my command, okay? But hope you are getting value. So type it there. The one you want me to do next. So this is what? Plus 2 plus 2x. This is, plus 2 plus 2x. This is 7 times minus 2 is what? Minus 14 equals to 0. So from here you can see that plus 2 minus 14 is what? Minus 12 equals to 0. Then 2s equals to what? 12. Then s equals to what? 12 divided by 2. Then s equals to what? Plus 6. Plus 6. Okay. So from here I know that this is what? Plus 6. This is plus 7. This one is my JAMB question. The reason why I missed this question was I just solved it at first. It was when I was coming back and I realized, this is wrong. That was why I had to retrace it and I got the answer. Okay. So please don't make the same mistake. As I've taught you now, you already know it's a likely question. So now Let's go. This one very easy. NaNO3, everything equals to 0. The rule plus 1. This is group 1, so plus 1. I need nx, then 3 times minus 2 equals to 0. Then plus 1 plus x minus 6 equals to 0. Right? Plus 1 minus 6, that's what? Minus 5 equals to 0. Then s equals to what? Plus 5. So that's why we named this guy as what? Sodium trioxonitrogen triazonitrate 5. Sodium triazonitrate 5. So on this now, you should be able to solve any question. So let me give you your own to solve. Let me give you your own to solve. So right. So let me to solve this. Calculate the Australian number of chlorine in KClO3. So just calculate for chlorine. Drop it in the comment section. If you don't do it, I will not solve another one again. Okay. Now, helium is often, that's 27. Helium is often used in observation balloons because of dash. Now, don't forget that helium is the second element. He is a noble gas, right? It's not an inert gas, it's a noble gas, right? Noble gas, group 8 element. When they say something is noble, everybody wants to be like them. But that's by the way. So, what am I trying to say? Hydrogen is lighter because hydrogen is what? Group. Hydrogen is 1. But helium is used because of two things. It is also light and it is non-combustible. It is what? Non-combustible. Unlike hydrogen that it is also light but combustible. So if you have something that you want to use in an observational balloon, you would have seen that balloon that is just going. But we want something that is light but non-combustible, because what's the essence of using you and you're also burning? You're bursting, you're combusting. Okay. So that's why helium is used. So it's because of two things. It's light. Yes, it met the criterion for hydrogen, but the other one, hydrogen did not meet it, non-combustible. So that's the reason. So it's a JAMB question. Oh. All right, so let's go. Coal gas is a mixture of dash and no, sorry, 28. The relationship between oxygen and ozone. The relationship between oxygen and ozone is dash. I already taught you. It is what? They are allotropes. Allotropes. They are both gases, but they have different composition, chemical composition. So they are allotropes. Very easy. You don't need to disturb yourself. They are allotropes. Okay? I already taught you that. Now, coal gas. Coal gas is one of the product of destructive distillation of coal. Destructive distillation. That is in the burning of what? Of coal in the absence of air. So coal gas is one of them. So gas, just like you can see, coal gas. So because it is coal gas, what do you think of? They must contain gases. So it is CO, carbon 2 oxide, hydrogen gas, and what? And methane. And you know that methane is what? CH4. So those are the gaseous mixture in what? In coal gas. Don't worry, there are 4 major products of them, of in DDC, destructive dissolution of coal. DDC. Okay. Dash and dash are responsible for temporary hardness. Now, and dash are, so 30 and 31, they are both on water, right? And you know water is tasteless, water is odorless, water is colorless. But most of the time we use the word insipid, almost tasted. That's what insipid. That's why diabetes insipidus is talking about excess water, diuresis. So, but what is responsible is that is calcium hydrogen carbonate, right? Like this, and magnesium hydrogen carbonate. So this is what is responsible for what? Temporary hardness. Temporary hardness. Dash and dash. So it's these two guys that's for what? Temporary hardness. Because we're talking about hardness of water. But if you are talking about permanent hardness, it's still the same thing, but it is sulfate of it. It is the sulfate of it. So just note that sulfate of it. That's the concept. I just want to know, because this guy is temporary hardness. This is what? Permanent. That's why this guy, you can use what? You can use eating. So one of the ways of removing temporary hardness is by eating. By the time you eat this guy, you will now realize that you have something like CaHCO3 bracket 2. So this guy can eat up, but you cannot eat this one and decompose it. You cannot eat it. In fact, most of the time they are not decomposable. These two guys. So that's why when you eat this guy, you now be seeing something like CaCO3 CO2 and H2O. So that is why this guy is what is deposited at the what inner layer, inner part of what of kettle. So we call it fluorine of kettle. That's why temporary hardness cause it. But then you are removing it through eating, it will cause it because of this. And another effect that we need to talk about is what stalagmite and stalactite. Stalagmite, mite is from top, stalactite is from down. So they now form a cave. Ah, chemistry is sweet. It's sweet. Say chemistry is sweet in the comment section. Chemistry is sweet in the comment section. Chemistry is interesting. All right, so that's that. Stalagmite and is another. Is a question in JAMB. Which of them will cause is what is temporary hardness that will cause that? Please take note. Aside from forming of kettle, can form stalactite and stalagmite cave. All right. So now I've explained this like that. So this is magnesium sulfate, calcium sulfate, magnesium hydrogen triazocarbonate, calcium hydrogen triazocarbonate. That's the answer. Now, township supply of water. The reason why I have to do this is because it's a whole lecture, but I will teach it here. Township supply is what they call municipal supply of water. You know, water has different sources, right? You know, you can have water in lakes, you know, in spring, in river, tap water, ocean, rain. You know, those are different sources of water, right? But this water might not be useful in township supply when they want to deliver water to the town. So it must undergo some processes of purification. And that process is because they are majorly four. They cannot be addendum, but they are majorly four. And that major form is the way I used to know it and the way I used to teach is that I have a mnemonics. And what is the mnemonics? You have to say this one. Can can CD can CD filter this? This one, if you don't write in the comment section, I will know you are not following me. But yeah, put in the comment because this one is important. What did I say? Can CD filter this? Can CD filter? That's why I have to teach it like this. And I have to 1, 2, 3, 4. That's the process of what? Purification of what? Municipal water. That is township supply of water, like to the town. You know, some places that you are now, they deliver water there. So, what is the can? The can is what? Is coagulation. The two, which is what? CD is what? Is sedimentation. The filter 3 is what? Is filtration. Then the number last, which is what? Is what? Disinfection. So that is the 4 processes. Can CD filter this? Can CD filter this? Can CD filter this? Very easy. So if you want to join our JAMB class, here is your bet. You can go to my WhatsApp, send me a message on WhatsApp, or you can message me on TikTok anywhere you're seeing this. Can CD filter this? Very easy. Coagulation, you use what we call the potash alum, right? Potash alum. I know some of you know it already. Potash alum bracket 2.12H2O. So this is a potash, is an alum. It can coagulate. So if it has coagulated, that means the fine particles that it has coagulated will allow it to sediment. So you go through what? Sedimentation. After that, it is already formed a coagulum, right? A flux has been formed already. So what do you observe? You allow that software to filter. So it will filter, you allow it to go down. Then the residue on top, they filtrate down. Very easy. So when it has filtered, there are some things that you now need to disinfect by what? Sometimes they use chlorination and different things to disinfect. Okay, because that's why they will tell you that chlorine kill germs, right? Fluorine, what? In fact, I think it's a germ question too. Yes, chlorine is for germ to kill germs, but fluorine is for what? To strengthen the teeth. Fluorine, that's why your toothpaste are fluorinated to strengthen the teeth. That's a jam question. Those two things I just said is a jam question. Okay, so that's the answer. Coagulation, sedimentation, filtration, and what? Disinfection. That's the process. That's why you must know this. Can CD filter this? All right. The acid anhydride that produce weak acid is dash. Now there are a lot of acid anhydride. So when we talk about acid anhydride, what do we say? Acid anhydride, right? They are oxide of non-metals, which when dissolves in water, they can form what? They can form acid, right? After you dissolve them in water, but they are basically oxide of what? Non-metals, because we have basic oxide, which are oxide of what? Metals. So for instance, CO2 is an acid anhydride. CO is an acid anhydride. No. CO2, SO2, SO3. Right? Now, that is not where I'm going. Where I'm going is that these are acid anhydride. But if this guy reacts with water, this one will form what? H2CO3. Right? If this guy reacts with water, this guy will form what? H2SO3, right? If this guy reacts with water, this guy will form what? H2SO12. This is what? SO4, right? So if I can change this, because now I didn't put the option to this question, but if I'm talking about weak acid, you know that this guy is a weak acid, this guy is a weak acid, right? So you know what I'm saying. So if let's say the question has options, most of the times they will just put something like CO2, SO3, they'll put CO, they'll put like NO2, they'll put NO2 in the option. So you know that this one is a special one. Hope you know. But this one is a special guy. It's a mixed anhydride. It's an acid anhydride, but the reason why they call it mixed anhydride is because it produces two acids. This one is a must know before you go to your exam. Is a must know. It will form HNO3 and HNO2. It will form two acids. So they call it mixed anhydride. You must know that. So this is another JAMB question. This one is a JAMB question too. But the answer to this question is CO2. Just know that CO2, they will put this as option A, option B, option C. Maybe put other one like CO, but just know that it's CO2 because this is weak acid. All right, so that's very correct. That's very correct. That's the answer. 37. The constituent of baking soda that makes dough to rise is dash. Now, baking soda, most of you that cook at home, that make your pop off and all of those stuffs, right? You will know baking soda. But here is the thing: baking soda itself, right? The concept is this: for baking soda, sorry, is a mixture of NaHCO3 and edible acid like tartaric acid. Tartaric acid. So that's the mixture. So what happens is this: by the time you add your baking soda inside the flour or what have you, and you add water, now this acid now reacts with what? With this guy. By the time you add water to it, it will now react and allow this guy to release. You know, the concept of when NaCl or carbonate react with an acid, it must liberate what? Carbon dioxide is a concept. So it is the CO2 that allowed the rise of the dough, right? But what constituent of the baking soda that allowed that is what? Where is it coming from? You get it. Where is it coming from? Is it from A or B? Oh yeah, tell me. A or B? A. So that is. Tell me in the comment section. A or B? Just type A. It's A. So that's why the constituent is what? NaHCO3. Very easy. Now let's go. DDC. Destructive distillation of coal. Destructive distillation of coal. Destructive distillation of coal. Now, destructive distillation of coal is DDC. Is the process of heating up coal in the absence of air. Is the process of heating up coal in the absence of air. And they will give different things. They will give what I call 3CA or CA, but it's 3C. The 3 is for this. So the first one, they will give coke, they will give coal tar, they will give coal gas, and what? Ammoniacal liquor. Ammoniacal liquor. Okay, those are the 4 products that is being formed from DDC. Now, the last question here is steam over red hot coke. What is the product? Now, when you have steam over red coke, or what they say, sometimes we say red hot carbon, and steam, which is what? H2 gas. This is gas, steam. This guy will produce what? CO and H2. So this mixture in ratio 1:1 is what we call what? Water gas. Water gas. This is a JAMB question. There's another concept called producer gas. Okay, there's another concept called producer gas, but this in ratio 1 to 1. When coal, or what they call hot red hot carbon, this is red hot carbon over red or steam. Steam is gas, gaseous in ratio 1 to 1, CO and H2. I hope you learned a lot. You can see the way I'm sweating. I hope you've learned a lot. If you want to join our JAM class, you can send me a message here. Make sure you subscribe, most importantly, and tell me which video you want me to make next, which 40 questions you want me to create next. I'm going to create for you. I'm here for you, but make sure you support. Take us to the next 10K followers, 10K subscribers here on YouTube, right? Just click the subscription button. Make sure you send this to your friends. Share it to your friends. Go and send it to your WhatsApp groups, to that your class group, to that your study group, your group that I want to write JAM or what to write to YA. Go and send it to them. I use everything within me to make sure that you understand every concept I taught here. And I hope you learned something. Press value, type value in the comment section if you learned something, and make sure you subscribe to my channel. Send it to your friends, share it to your friends, go to your WhatsApp group. And as always, the chemistry tutor, and I'll meet you again where you want me to see you. If you're ready, take me to the next 10K. I'll post the next video. Yeah, take me to the next 10K. Thank you, thank you, thank you. Do it now. Share it to your friends. And yeah, JAM is less than 40 days and you must pass your exam. As always, the chemistry tutor. If you want to join our JAM class, marathon is going to happen. So a lot of things where we'll do 8 hours every day teaching. It's going to happen. So send me a message on WhatsApp and I will see you in my next video.